Hello, my name is Utkarsh Srivastava. I am pursuing my BS degree in electronic systems from IIT Madras. This is my identity card. Here you can see there is a diode and connected with series in with 1K resistor, and this pin of the diode has been connected from the supply voltage which is coming from channel A. It is 0 to 5 volt. Okay, we will decide it how much it is, and this point is for ground. But I found a bug here. The bug is related to ADLM kit, that when we give the voltage from the channels, voltage supply from the channels, then whenever I trying to measure that voltage with the help of these kinds of multimeter, so the voltage isn't so I modified the circuit. So what I did here, I taken the 5 volt supply and give it to this voltage divider circuit, and the output I will give it to the diode. Okay, with the help of this potentiometer I can vary the voltage, and I have connected two multimeters. This one is for the measuring the voltage across this diode, and this one I am using to measure the current. I set it to the milliamperes mode, and I will see the how much current is going there. Okay. In the oscilloscope you can see the voltage output which is coming from the potentiometer. So here you can see, as I moving the knob, the voltage across resistor is changing, and as the voltage is changing, the current going from the resistor, from the diode or resistor, is also changing, as you can see. For the changing the polarity of this diode, what I will do, I will give the ground voltage at this point, and the VCC, that means plus 0 to plus 5 volt, I am giving to this particular. So let's perform the experiment. You can see I am turning the knob, and by the turning the knob, voltage is changing, and but still the current and voltage from the diode is 0. You can see I got this final curve voltage versus current in diode. For the measuring the VI characteristics of the Zener diode, I connected a 200 ohm resistor with the series of Zener diode at the, this is the anode of the Zener diode. So I connected it to positive supply, and this is the ground. Okay. So what I did here, as previous one, I took I took two multimeters. The first one, this one is measuring the voltage across this diode. Okay, you can see the probes are connected there, and for measuring the current, I am using this one, this multimeter, and with the help of these pins, we will measure the current from, and I am giving the varying voltage with the help of this potentiometer. Okay. And for the reverse bias, basically I will change the polarity of the voltages. Okay. So after performing the experiment, I found this curve on forward bias, and for the reverse bias I got this curve. For the half wave rectifier, I built this circuit as per the circuit diagram. At the top least point of this resistor, I gave it 2.5 volt supply instead of ground, and channel A has been connected from this point, and the channel B from, with the help of this we can measure the waveform. So here you can see when I am giving the input sine wave with the 50 Hz frequency, so I am getting this rectified wave from the channel B. Okay. Now I am introducing a 70 nanofarad capacitor across this resistance, and see the output waveforms. So when I give 50 Hz sine wave, so output is looking something like that. For 100 Hz, it is something like that. For 250 Hz, it is like that. For 500 Hz, it is like that. For 1000 Hz, you can see, yeah, it is the output. Now here I replace the diode with LED and the 1K resistor to 220 ohms resistor. Okay. So here I set the frequency to 1000 hertz. You can see this is the output, and in the LED you can see. So here I introduce a capacitor across the RL resistor, okay, as we did in previous experiment, connecting the capacitor and see the very minor differences come. Yeah, you can see here. I'm just when I connected to the capacitor at here, you can see where I connected. Yeah, a minor difference come at here. Okay, thank you.